The following is a production of the Computer Information Systems Department at the Metropolitan State University of Denver. Hello and welcome. To begin our exploration of databases, I'd like to start by exploring the question, why do I want to use a database? I think this question is natural. After all, students often work with Excel, which often keeps track of data as a set of columns and rows, oftentimes with the column names at the tops of the columns. Then they see a database table, which also keeps track of data as rows and columns, with the column names at the top of the column. If it's all just a way of keeping track of columns and rows, why not stick with what you know, right? To answer this question, I'd like to start with a simple list in Excel. Let's pretend that this is a list of the children that make up a first grade classroom, as well as their parents and the parents' contact information. This list makes sense. It's simple, it would be easy to maintain, and we probably wouldn't expect it to grow very much. If we wanted to plan a party, we could add a few columns to keep track of things like, was an invitation sent, and is the invited child attending? And after the party, I might want to know the gifts received so that I could send thank you notes to the families that came to the party. Such a situation is a perfect use of a list because it keeps track of only one topic, the kids in a classroom. All of the columns or attributes just give me data about the kids in the class. Our textbook defines an entity as a distinct object such as a person, place, thing, concept, or event. So technically speaking, we could say that this list only keeps track of one entity, kids. Hence, there really isn't much need to go to the trouble of turning this list into a database. In fact, I would say that turning this list into a database is overkill. So let's look at another list. Unfortunately, this list was created in Excel by a brand new veterinarian who knew more about taking care of animals than he did about keeping track of data. The vet set himself up with a list in the form of an Excel spreadsheet that will keep track of the name and species of each animal that visits, as well as the owner of each animal, the owner's phone number, and the date of each visit the animal makes. It's clear that this list is keeping track of more than one entity. In fact, I think this list is trying to keep track of three entities: pets, owners, and visits that the pet makes to the veterinarian. In database speak, it would be correct to say that the pets, the owners, and the visits to the vet each represent a different entity. Let's examine exactly why we don't want to keep track of more than one entity in a list. I'll bet you can quickly identify some problems that are inherent to keeping track of all this data in a list format. Can you see any problems? The first problem that I see is that if any pet ever needs an 8th visit, we will need to add a new column. You can see that Kelly the lab holds the record at 7 visits. But if any other animal requires more than 7 visits, I've got to add an 8th visit column to accommodate them. Pretty soon, if I've got animals that I've been seeing for a couple of years, and if that animal tends to be sickly, I might end up with dozens or even scores of columns telling me how many visits the animal made. That just really isn't very efficient. The next problem I see is that Kelly Johnson owns 2 animals, Snooky the dog and Walter the pig. Let's pretend that Kelly Johnson brings in Snooky the dog, and during her visit she informs the receptionist that her phone number has changed. So the receptionist updates the phone number listed under Snooky the dog, which is circled here in a solid red line. You can see, however, that the phone number for Kelly Johnson as the owner of Walter the pig will not automatically be changed. This number is circled as the dotted red line. So if Walter needs a yearly shot, and the veterinarian wants to call and remind Kelly Johnson that Walter needs his shot, if the vet uses the number listed under Walter the pig, this will be an old number that probably doesn't work. This even though Kelly Johnson gave us her new contact information, but we recorded it under Snooky the dog. Another problem that is quickly evident is that there is no obvious or intuitive way to store the veterinarian's notes for each visit. Yes, we could have long text entries of when the visit occurred, the diagnosis, any prescriptions or procedures that occurred, and any suggested follow-up. But this isn't very useful, and it's certainly not going to be very easy to view this data or search through it. For example, if Chance the dog came in with a thorn in his paw, and the vet had to remove it and prescribe antibiotics, the entry might look something like this. This is obviously very clumsy, especially when you start to get a few thousand entries, which you would probably do within just a few months of opening your vet clinic. So, what to do? Let's back up and just simply think about our data in a logical sense. In reality, the relationships between the owners and pets actually look something like this. Kelly Johnson owns Snooky the dog and Walter the pig. And Mike Black owns Fatty the cat and Zip the turtle. Here we have two types of things, two entities, people and animals. The relationships between the owners and their pets are represented by the blue lines. Hopefully, this diagram is intuitive and makes sense. What we'd like to do is represent this diagram in a way that a computer can understand. To do this, we could come up with a series of lists. One list could keep track of people, and a second list could keep track of the animals. What we don't have, at least not in Excel, is a way to keep track of the relationships between the people that are in one list and the animals which are in another list. This is where databases come in. Databases allow us to keep track of relationships between the entities in different lists, or tables. Databases can map the records from one table to the records in another table. I cannot stress strongly enough how big of a deal this is. In our example, the ability to map relationships between records means that I can record information about Kelly Johnson in one table, and that data can then be referenced for any number of pets. For example, I can say Snooky is a dog and her owner is Kelly Johnson. If I want to know something about Kelly Johnson, like let's say her phone number, I do have to jump over to the owner list and retrieve that information about Kelly Johnson. This exact same information can be referenced by Walter the pig. Walter is a pig, his owner is Kelly Johnson, and to find out Kelly's phone number, I jump to the owner table and look at the phone number. Seeing this, I now understand that if I change Kelly's phone number once, every animal that references Kelly Johnson will reference the same new phone number. In effect, I make one change for Kelly Johnson, but it has the effect of changing the phone number for every animal owned by Kelly Johnson. So let's do a quick review. In databases, we think of each actor or event as an entity. In the case of the veterinary clinic, the human pet owners are one type of entity, and we can keep track of them in what is effectively a list of owners, or a table. The pets are another entity, and we can keep track of them in a table of pets. The advantage of a database is that it can keep track of the relationships between the owners and the pets, even though the information about owners and pets are stored in different tables. Let's expand on this example a little bit more. It is safe to say that we would want to keep track of each time the pet visits us. So we could keep track of visits in a pet interaction table, and we could also keep track of procedures that occur during a visit, such as spaying an animal or extracting a tooth, in a procedure table. The diagram below shows us some tables that we could create to keep track of owners, pets, interactions or visits, and procedures. For example, for each owner, it would be ideal to know the owner's first and last name, their home, work, and cell phone numbers, and also their address. For each pet, we would want to know the pet's name, species, possibly its breed, its date of birth, and also maybe the date of its death. For each visit, again, what I am calling an interaction, we would want to know when the interaction occurred and where the interaction occurred. We would also want to know if any procedures, such as a bath, extracting a tooth, or giving a shot, occurred. we would keep track of that information in the procedure table. As you can see, our database is very scalable. For example, we could start to add tables and information about billing and insurance without having to alter the data we currently have. So far, we've explored how, in some cases, we might want to keep track of data within database tables instead of simple lists. The next obvious question might then be, how do I keep track of the relationships between tables? As you can see, these relationships are extremely important. They allow us to create structure and context for our data. Understanding these relationships is going to be a major focus of this class, and we will explore the relationships between tables much more as the class progresses. So let's review. Oftentimes, a list can be a very simple way of keeping track of data. Sometimes, however, a simple list is not sufficient to keep track of complex data. If a list keeps track of more than one topic, it might be time to think about using a database, which can keep track of several lists, which in a database are called tables. We often call the topics in a database entities. Entities often refer to things such as people or pets, or events such as visits to the vet or surgery. The true power of a database is that they can also keep track of the relationships between entities. We will explore the relationships between the entities as we progress through this class. I hope this video helped you understand a little bit more about why we use databases and the difference between times you should just use a list and when you should use a database. I know we didn't get into the specifics of how a database works, which is okay. That's a big topic that we will spend the next several weeks exploring. Thanks for watching.